So missing values. This is a very important part, and I just gave you a really good example of as well of the problem of missing values and how you can't use it in modeling. And what do? Do you get rid of them? That's a whole nother. I'll go over that in more detail in our data cleaning and data munging class that we have, and how when we go over setting up data to be used in a machine learning model. We're going to get into that more. But this is basically what I'm telling you here are the types of missing values. These are the main ones. So NA means not available. It's missing, and it just puts an NA where the column is blank. NaN is not a number. So basically, an example is finding the square root of a negative number. That's going to return this because the definition of a square root, you cannot find the square root of a negative number. It's just mathematically impossible. So you can't do that. A null object it will be returned from a function if the function is undefined. So if you try to loop through something and then the value doesn't exist, it's going to return a null value. So the big difference, missing values has a length of 1. And this null has an empty value with a length of 0. Infinite is basically going up to infinity. It's another mathematical concept. It will be returned if you try to divide by 0. That is out of the scope of a programming class, but that is due to like math rules, has nothing to do with R. But these are the ones that you'll see most often. So I'm going to go in and show you, or I'll show you here and then go in. Oh, are there any questions about this? Actually, we're going to go in and do a demo. So when would NA be returned? So say you have a data frame or a matrix and you're dividing everything by 10. If you divide NA by 10, it's going to return NA. You see this also with the sum function, mean function. If you have NA values, it's going to return NA unless you put NA.rm equals 0, equals true, sorry. Here's the example. 9 divided by 0 is going to return infinity. So that's the biggest, you see that most often when it divides by 0. The other thing I wanted to show, the length for a null value is 0. So it is stored. It's basically not taking up space. It has a length of 0. Whereas if you take the NA, it's actually stored as a value, that NA value. So that shows you a little bit of difference between those two. Are there any questions about this? This is very similar to a lot of different programming languages. Although in SQL, null is equal to missing. So it's a little bit different, but there's always different types and it gives different information.
Yeah, null is undefined.
Okay. Yeah, but in general, yeah, so that's another way to put this. Yes, undefined. Okay, so another real world example, and this is very similar to what I showed before. So how would you look at missing values? Say I have not. Just gonna run all of this. So now we have our world data frame in here. So this has 225 rows. I explicitly chose the world data frame because it has a ton of missing values in it, just because it would be good to show you this. So say we wanted to look at the NA values within world.df. So we have is NA, and it shows you which ones are missing, which ones are not. This is not super useful here because we're just printing which ones are NA, and there's a lot of values in here. That's not going to help you. When you're trying to look at how many missing values there are in a column, you'll put is NA inside of a table column, and it'll return that there are 96 that are NA, and there are 129 that are not missing, compared to the 225 number of rows up here. So basically, 96 of the 225 rows are missing. So if you were really doing an analysis with this, that would be a huge red flag. And you, in a lot of cases, I would probably never use this column because it's not going to give us accurate information. So one way, you can do this with dplyr as well, which is usually how I do it. But in our data that I uploaded, made a mistake in the column names on purpose so I could demonstrate this. We have world.df. And I'm just going to show it in here, and I'm going to show it down here. So you're seeing poverty less than, so on and so forth, in column 17. So we come over here, we're seeing that. This is a typo. So whoever created this made a typo. In this case, me, but it was on purpose to show this. So in order to use indexing, we went over column names in a different class. So when you do this, it's going to return a vector with all the column names. You can see it up here. And class, if you did this, it's a character vector. So we have that here. So we are referring to the 17th value within that world.df. And I want to change that 17th value. And if you print this, it's going to be poverty, the typo. And I wanted to replace it with poverty, which is the correct value. This is how you would do it. So you're basically indexing that world.df as a vector and pulling the 17th value in that, and we are replacing it with an assignment operator. So that's a very simple example. This is something that I would use in practice. So this will have the same structure as what we've seen before. We have world.df and we have our country variable within it. I want to change, in this case, every time the Virgin Islands shows up in this column, I want to change it to US Virgin Islands instead of having parentheses. So that is a use case that you would see pretty commonly. We have our first column, so we are indexing that particular column. We keep it as this because we are specifying a specific column and we are using that instead of trying to explain this in a way, because it is confusing that, and before we've had the world.df here. So since we are only looking at these values here, the country within this vector, and you'll see that there's no comma here. So that is, I guess, the best way to explain this. So world.df is kind of being pulled out as a vector. You can think of it as that way. And there is no comma and then blank. So we are only dealing with that particular value within this data frame. So only the country. And since we don't have a comma here, and we're referring basically to that column only, that's why you have to have the world.df and the country listed first. I have never done it this way, but I'm assuming if you wanted to, you would be able to take this country out, put a comma in, and maybe change it that way. Although for some reason I've never done it that way. We could try at some point. So if we do go into this world.data now, let's sort this. If we go down to the bottom, we have US Virgin Islands. It no longer has the parentheses in it. So that's something that I would do a lot in practice, exactly like this. So say you're doing a looping exercise and you have some missing values in the things that you want to loop over. If you have an NA in there, it's going to kill the entire loop. It stops the processing of the loop. But say you want it to keep going, and then you can just account for this, whatever blank there is, and put a blank row in there, for instance, when you get to that part. So in this case, we're going to take again that in this case, you would basically be replacing the NAs with a blank, which then does not kill the loop. It's just a rule, and that's how it works. So we have this world.data frame, and then we're referring to the percent tobacco use adults in 2005. It has a lot of missing data, so this is something I might want to do. And we are going to refer to is NA and then have that same column in here. If you try to put world.data frame and then percent tobacco use equals NA, it will throw an error. It requires you to always use this NA, is NA vector. And then it's taking those blank values. So what this will be doing is where it equals NA in this column, it will replace with a blank. So if you come in here, and this is in the slides, world.df, you'll see here there versus where we did not replace the NA values, you'll see that it is blank here versus NA. So that's what we're seeing here. And you can see the difference by looking at this. So that's something I use quite frequently if I'm having to do a loop. And just to show you again, if we use is NA, now they're all false because they're blanks, not missing values. And then if we look at the table, they're all false. They're not missing anymore. Therefore, a loop would work over this.